Welcome to Kannateri Institute of Chemistry. Today we will discuss the topic Empirical and Molecular Formula. In this video, we can see details about the percentage composition, how to find the percentage composition of an element, what is meant by molecular formula, what is meant by empirical formula, how empirical formula and molecular formula are related with each other, then problems for finding empirical and molecular formula. Details about my academic and professional experience are given here. Now we will discuss what is meant by percentage composition. The percentage composition represents the percentage of an element in a compound. It is determined using the formula mass of the element in the compound divided by molar mass of the compound or molecular mass of the compound, that into 100. Now we will see a problem to find the percentage composition. The problem given is find the percentage composition of potassium, chlorine and oxygen in potassium chlorate or KClO3. The atomic masses of the elements are given in the problem itself. Atomic mass potassium K is equal to 39, chlorine Cl is equal to 35.5 and oxygen O is equal to 16. To find the percentage composition, first of all we have to calculate the molar mass of potassium chlorate or KClO3 by adding their atomic masses. We know that potassium chlorate contain one potassium atom, one chlorine atom and three oxygen atoms. So atomic mass of potassium 39 plus atomic mass of chlorine 35.5 plus atomic mass of 3 oxygen atoms. So 16 into 3 and altogether you will be getting the value 122.5. So the molar mass of potassium chlorate is 122.5. Out of that, potassium constitutes only 39 gram. So what is the mass percentage of potassium? We have the formula mass of the element divided by molar mass into 100. In the case of potassium, mass of the element is 39. Molar mass we have calculated it as 122.5. So the value will be 39 by 122.5 into 100. And you will get the result as 31.83%. Now we have to calculate the mass percentage of chlorine, Cl. For that, again we have to repeat the formula mass of the element divided by molar mass into 100. Here mass of chlorine is equal to 35.5. Molar mass is equal to, we have already calculated 122.5. So 35.5 divided by 122.5 into 100. That will give you the result 28.98%. Now we have to calculate the mass percentage of oxygen atom. Again, I repeat the formula mass of the element divided by molar mass into 100. Here there are 3 oxygen atoms. So mass of the element becomes 16 into 3 or it becomes 48. Molar mass we have already calculated it as 122.5. So the result is 48 divided by 122.5 into 100 is equal to 39.18%. Now we have to know what is actually meant by molecular formula of a compound. Molecular formula represents the exact number of the different types of atoms present in a molecule of the compound. For example, the molecular formula of hydrogen peroxide is H2O2. The molecular formula of benzene is C6H6. The molecular formula of glucose is C6H12O6. Now we will see what is actually meant by empirical formula. Empirical formula represents the simplest whole number ratio of the various atoms present in a molecule of the compound. For example, the empirical formula of hydrogen peroxide is HO. The empirical formula of benzene is CH. The empirical formula of glucose is CH2O. We know that the molecular formula of hydrogen peroxide is H2O2. So in it there are 2 hydrogen atoms and 2 oxygen atoms. So their simplest whole number ratio is 1:1. That is why the empirical formula of hydrogen peroxide becomes HO. In the case of benzene, the molecular formula is C6H6. That means there are 6 carbon atoms and 6 hydrogen atoms. So the simplest whole number ratio between them is 6:6 or 1:1. That is why the empirical formula of benzene is CH. In the case of glucose, the molecular formula is C6H12O6. So the simplest whole number ratio between the atoms is 1:2:1, or the empirical formula of glucose is CH2O. Now we have to see how this empirical formula and molecular formula are related with each other. Molecular formula is equal to n into empirical formula, where n is equal to 1, 2, 3, 4, etc. The value of n is determined using the formula molecular formula mass by empirical formula mass. Applying this in the case of benzene, whose molecular formula is C6H6 and empirical formula is CH, we can see that the molecular formula of benzene is 78. How we got it? 6 carbon atoms, that means 6 into 12 plus 6 hydrogen atoms, that means 6 into 1. So altogether we get the molecular mass as 78. Its empirical formula mass is only 13. Why? Its empirical formula is CH, 1 carbon and 1 hydrogen. Carbon atomic mass is 12 plus hydrogen atomic mass 1. So altogether we get the empirical formula mass as 13. So if we calculate the n, we will get molecular formula mass divided by empirical formula mass, that is 78 by 13, or is equal to 6. So to convert empirical formula of benzene into molecular formula, we have to multiply empirical formula by 6. So CH into 6 is equal to C6H6, and that is the molecular formula for benzene. Now we will see a problem to find empirical and molecular formula. The problem given is a compound contains 54.55% carbon, 9.09% hydrogen, and 36.26% oxygen. Its molar mass is 88 grams. Determine the empirical and molecular formulas of the compound. First, we will find the empirical formula. For that, we have to make a table containing 5 columns. The first column stands for the different elements in a molecule of the compound. The second column stands for their percentage composition. In the third column, we will divide the percentage composition of each and every element by its atomic mass. And in the fourth column, whatever the smallest factor or lowest quotient we get in the third column, with that we will be dividing every quotient. In the fifth column, we will be writing the ratio of the number of atoms as whole numbers. Now we will come to this specific problem. In this specific problem, we have 3 elements: carbon, hydrogen, and oxygen. And the percentage composition of these elements given are carbon 54.55, hydrogen 9.09, and oxygen 36.26. So to find the relative number of atoms, we have to divide the percentage composition of carbon 54.55 with its atomic mass, that is 12. That will give you the result 4.54. Coming to hydrogen, its percentage composition 9.09 has to be divided by its atomic mass, that is 1. So the result also will be 9.09. Coming to oxygen, its percentage composition 36.26 has to be divided by its atomic mass, that is 16. So the result will be 2.26. And out of these 3 quotients, we find that 2.26 is the lowest quotient or smallest factor. So in the fourth column, we will be dividing each and every quotient with the smallest quotient or smallest factor. So in the fourth column, you can see that 4.54 divided by 2.26 is equal to 2.008. Coming to hydrogen, 9.09 divided by 2.26 is equal to 4.022. Coming to oxygen, we can see that 2.26 is getting divided by 2.26, the smallest quotient or smallest factor. So the result is only 1. In the fifth column, we have to write this in terms of whole numbers. So against carbon, the nearest whole number is 2. Against hydrogen, the nearest whole number is 4. And against oxygen, the whole number is 1. That means in the empirical formula of this particular compound, there are 2 carbon atoms, 4 hydrogen atoms, and only 1 oxygen atom. So we can write the empirical formula of this compound is C2H4O. Now we have to find the molecular formula. We know that the molecular formula can be obtained by just multiplying the empirical formula with a number n. And how that number n can be found? By dividing the molecular mass divided by the empirical formula mass. The molecular mass of the compound is given in the problem itself as 88. Now we have to find the empirical formula mass. We got the empirical formula as C2H4O. So the empirical formula mass is 2 carbon atoms, 2 into 12 plus 4 hydrogen atoms, 4 into 1 plus 1 oxygen atom, that means 16 is equal to, altogether we will get it as 44. So what is n? Molecular mass divided by empirical formula mass is equal to 88 divided by 44 is equal to 2. So the molecular formula of this compound will be n into empirical formula. That means 2 into C2H4O, or it will be C4H8O2. Do you find this video informative? If your answer is yes, please like, share and subscribe. Your support is really meaningful to me. Thanks a lot and see you next time with a new topic. A big thank you.